Okay, so I think a lot of you are dancing with number 2. Okay, need to consider. Now I'm going to say this could be a blind alley. Okay. Yeah, like that one problem. So there we've got an expression that relates the delta y max to the vi y delta t plus 1/2 a delta t squared. Now we would have a way to connect that back to the x-axis through delta t. But what we need is a way to connect this vi to the point at which vy zeroes out. So what we need to do is go back and look at the expressions that connect vi and vy, and possibly delta t. So let's see, vy equals vi plus a delta t, that's one. So this would be vy, or I'm sorry, that's vf. But we're looking for, for a discrete point in the flight, we can call that a vf. We can arbitrarily say, okay, we're looking up to this point. So vfy equals vi plus a delta t, and this of course would be ay. We've got that. We have a way to build an expression for delta t, and this would be viy, so it would be sine theta vi plus a delta t. And let's see, delta t equals delta x over vix. So that's vfy. And we would want to rearrange that to solve for vi. So, like I said, this could be a blind alley. So, vfy minus a delta t divided by the sine of theta is equal to vi is equal to vi. I'm puzzling over this piece. So if we solve this for viy, then we would have an expression for viy, not vi. Okay. But that's the kind of, repeated substitution that we're going to do. Well, because if you're going to think about the top of flight thing, you're thinking about a point where vy goes to 0, and that's going to be a sort of internal vf. Right. And so we're thinking about that change in velocity. And so we're thinking about ways to substitute that back in. Okay, so if I go the other path, the other potential path, and I just keep doing this, and I solve for viy, then I get vfy minus a delta t equals viy, and let's see. I'm pretty sure that sign is gonna have to come out of there at some point. Because of course viy equals vi. Yeah, so you're gonna have to divide that by sine of theta. Arg.
We can't see what you're writing.
Yeah, I know. I'm not writing anything. I'm just trying to move the text. Okay, so then if that was the case, that gets us vi, and then we could plug that in there. I'm going to keep fighting with this, but I'm going to have to fight on paper because I don't fight well on here. Okay, so let's forget all of that. I didn't erase. Okay, so what I did was I created the following expression. I looked at delta y overall is equal to VIY delta t plus 1/2 a delta t squared. True. Now, there's something you can do because overall this ball is hit at ground level and it returns to ground level, which means that this is 0. Which means that 0 equals VIY delta t plus 1/2 a delta t squared. Which means you can do the following weird freaky thing. Negative VIY delta t equals 1/2 a delta t squared. You with me? Okay. Well, now we go ahead and we can factor out the 1 delta t. So we can pull 1 delta t out of the problem. So we have negative VIY equals 1/2 a delta t. Okay, you good with that? Okay. So now I take negative VI sine theta equals 1/2 a delta t. So now VI equals negative 1, because I removed that, I took that negative sign and made it a negative 1 and moved it to the other side. Hold on. Let's see. Negative 1 a delta t over 2 sine theta. Okay, so I now have an expression for VI. There's just one problem. I still have a delta t in there. So let's go back over and look at the expression that we got here. So delta t equals delta x over VIx, which means delta t equals delta x over VI cosine theta. Now, this was delta y overall, which means we are looking at the entire flight path of this ball right now, which means we have a delta x, okay, which is the 301.5. We're not ready to plug anything in. Don't even think about it yet. But that means we can take this and stick it in here. Now, the algebra is going to get real ugly. I'm just going to warn you. I mean, I love algebra like I would do algebra for fun, and it kind of freaked me out for a minute. I wasn't sure that it was all legal. Algebra, so much fun it should be illegal. Okay, it's going to get ugly, but it's okay. Don't be afraid. VI equals negative 1 a delta x over, let's see, where did I stick that in? There we go. Over VI cosine theta over, oh, okay, now over 2 sine theta. Okay, here's where the algebra got a little bit funky. So I need to get both of those VI's together, and here's how you do it. Alright, so VI equals negative 1 a delta x over VI 2 sine theta cosine theta. So then I can multiply both sides by VI. Okay, so I get VI squared equals negative 1a delta x over 2 sine theta cosine theta. So of course I can take the square root of this whole mess and get rid of that. So there's an expression for VI. Whew! Alright, I haven't got any further than that yet. Use this anywhere. You related factors from the overall path. You related the overall y and overall x displacement to the VI. We'll pick it up tomorrow.